guys, this is your greatest common factor day 2 notes. And you might be wondering why the heck we're doing this again, but I wanted to show you a different method for those of you that maybe are pretty good at knowing your factors. I know some people hate factor trees, which is what we've been doing. So if you're one that hates factor trees, today might give you a new way to find the greatest common factor without having to do those factor trees. And I personally love this way of doing it because I always disliked factor trees with a passion. So just to kind of refresh our memory, how do we find greatest common factor with those factor trees? So prime factorization. Remember, you had to start with 2. So 2 times 8, 2 was prime, kept going with 8, 2 times 4, and then 4 was 2 times 2. So to me, this is just so much work. It's a little crazy because I got to do it twice. So again, I start with 24, so 2 and 12, 2 and 6, and then 2 and 3. All right, so with your factor tree, which is what we've been practicing, you list out your factors. So I have 2, 2, 2, and 2 for 16. And I have 2, 2, 2, and 3 for 24. So then you have to go back and circle your terms that are alike. So I have 3 2's that are alike. So I have 2 to the 3rd power, which gives me 8. So 8 is my greatest common factor. So that takes a little bit of time. Hopefully you're familiar with it because we've been practicing it. But your greatest common factor of 16 and 24 would be 8. Now let me show you the second method that you might like a little better. It's for the same 2 numbers. So I'm going to find the greatest common factor of these terms using listing factors. So what I mean by that is you're going to list all of the factors that you can get for 16. So always start with 1. So 1 times 16 will give you 16. 2 times 8 will give you 16. 4 times 4, and then I'm back to where I was at. So these are all my factors that will give me 16. I'm going to do the same thing for 24. So start with 1. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and I'm back to 6. So a little bit simpler than the factor trees, I think, if you know your factors. And then I'm going to look and see what is the greatest number that they have in common. So I always start with the biggest number I see. So 24, 16, 12, 8. So 8 is the number they have in common. So to me, this method is simpler, faster, if you know your facts. So I'm going to show you today in today's notes this method, and hopefully you guys will get the hang of it, and then you can decide which method you like better, the factor trees or this new way of listing factors. So both ways will help you find greatest common factor. It's just your preference, so what you like. We're not going to do all of these right now, but I wanted to show you how this works. So let's try it again. So instead of doing my factor tree, I'm going to list out all of my factors of 15 and 75 and see what they have in common. So to get 15, I could do 1 times 15, 3 times 5, and that's really it for that. For 75, I have 1 times 75, 3 times 25, and then 4 doesn't work, 5, and 15. So right away, I see the biggest number they have in common would be 15. So that is my greatest common factor. Now 5 they have in common, 3 they have in common, but remember this is greatest common factor, so the number they have in common. All right, we're going to skip this one for now. I would encourage you to try that one on your own. But let's jump down here to number 3 because I see some exponents here. So factors of 42. I have 1 and 42, 2 and 21. Let me pull up my calculator here. If you don't know your factors, just to show you what you could do is just do that, what's divisible by it. So if it's divisible by 3, so we have 3 and 14. Does 4 work? I don't think it does. 42 divided by 4 doesn't work. 5 doesn't work. 6 works, so 6 times 7, and then I'm back to 7. So if you don't know your factors very well, or if it's an unfamiliar number, just remember to figure out what's divisible by that. All right, 54 is another one that's not too common, so you might have to use your calculator. So 1 times 54, 54 divided by 2, so 2 and 27. 54 and 3, I don't think that will work. Oops. It's going to give you 18, I was wrong. 54 and 4. Oops. So this way, if you don't know your factors, like for these strange numbers, it might take you longer than just doing your factor trees. So you have to determine what's going to be better for you. All right. So you have all your factors here. You're going to see what they have in common. So we have 9 doesn't work, 5. So really the biggest number these two numbers have in common is 3. So that's your greatest common factor. Now for this problem you have exponents. So remember, greatest common factor is how many they each have, at least how many of. So I see they both have an x. They each only have at least 1. They both do not have a y, so that would not be your greatest common factor. Okay? Alright, so I'm interested to know when you come into class tomorrow what your preference is. Do you like the factor trees, or do you like this new method of just listing out factors? So come in tomorrow. The secret message technically for tomorrow is going to be for you guys to tell me what do you guys prefer and why. Alright, so I will see you guys tomorrow. Be ready in class. We're going to go through example 2 and example 4 together. So you might want to get a head start and try those out tonight.